See, I was about to go live, but then like that whole riff happened, and how could I not? Because it was so good. And that's actually open source music in the YouTube open source library, and shout out to the creator from that because yeah, I was fully getting into it in the International Space Station, no less. Anyway, let me turn that off. And hello and welcome everyone. We have been on a bit of a hiatus, but we needed some time to retool some couple things, and there's still a few things in play. But anyway, we'll get into that in a little bit. Let me do the share screen thing so we can do all the intro bits. I need to switch a couple of screens around in the International Space Station because it's what you do in space. But hello and welcome. Thank you all for joining us for the first Oz IoT for the year. Hope you all had an amazing break and were able to work on all those IoT projects. I know we always keep those for the end of year breaks because, well, it's often the only time we get to be able to do things. And I'm going to talk about a couple today, including one that we talked about in the Discord. Speaking of the Discord, if you haven't yet joined us, I've dropped the link into the chat. So please jump onto the Discord because at the end of the night, I thought if there's some people around, we could jump into the audio channel on there. Or I think there was Craig wanted to also use Zoom. So open to either. We'd probably talk about it in Discord or pop it into the chat. No Remo. No Remo this time. No Remo this year. But we are looking at some alternatives. So Timothy just asked whether we're using Remo, and not this year, but we're looking at some options. So actually, if anyone has any recommendations or anything they want to suggest, please drop it into the chat or on Discord, because we are always looking for new ways. So please reach out. Anyway, so amazing you're here. We have a really, really cool talk tonight. I'm going to say again that it's a little bit out of this world, but we'll get into that in a little bit later on. So before we, well, that wasn't a good start now, was it? I'm going to switch over to my slides. Before we begin, I'd like to pay my acknowledgements and respects to the traditional owners on the lands on which we meet today, including the Wurundjeri people, who are the traditional owners on the lands in which I'm presenting from, which is out in Western New South Wales, Central West New South Wales, rather. Please, as we go through tonight, drop into the chat any questions, comments, emojis. We always thank emojis because we like chat with a little character. Oh, there we go. Oh, and it's doing it again. I think my Mac graphics card's getting a bit unhappy. Anyway, drop also into the chat where the lens that you're on today, and just to acknowledge the traditional owners of where you're at. So tonight we have a really cool talk lined up from Andrew Bate. Now, we had a meeting a few weeks ago, or we met a few weeks ago, and well, we geeked out the entire time. So this is going to be a really cool talk, particularly because I know AWS to Edge is something I've been interested in for forever. Like, how does it work? What does it do? Well, we know what it does, but all the nuances to it we're going to be looking at tonight, plus some interesting space stuff. But I'll keep that for the talk because I already know the spoilers. So. And then, like I said, we can jump into networking either on Zoom or on Discord, just because it's always great to geek out, chat, and say hi to everyone and see what everyone ends up to. And also, there's usually some cool projects that someone's working on. We do have a code of conduct. I'm going to switch back to StreamYard and drop that in there now. So if you haven't yet had a look at the code of conduct, I mean, basically, it's just be excellent to each other, as I always like saying, and in the words of the famous Bill and Ted. Yeah, I think they're famous. I'm going to say they are. Is just be excellent to each other. And I mean, usually, well, that's what this group's all about. Just sharing stuff, geeking out, talking tech. But anyway, I did say I was going to drop that into the hello, Craig. And hello, everyone. I'm going to drop the code of conduct into the chat now, and then hopefully there we go. So tonight's sponsors is Sneak, hello, and also the amazing AWS. Now, that is unrelated to the speaker tonight, who is also from AWS, you may have noticed from the meetup. AWS reached out over January and wanted to sponsor. So we have more information coming up on that but basically they're going to be, we'll have some prizes to give away, and we're looking at doing some raffles and a couple of other activities, but some really cool swag, just saying. AWS socks, I've already had, I've got a few pairs from previous adventures, and they're always fun, along with t-shirts and some other goodies as well. So stay tuned for that one, working close with the US folks on that one as well. Now, we are looking for some volunteer organizers. So if you've never run a meetup before and you want to get involved, or just want to see how you can help, please reach out and on the Discord or on any of our socials, on the meetup page, and we'd love to talk to you and get you involved. Always looking for people to help. So wait, before we get into news and cool stuff, I'm going to switch back over to, I need another like 3 screens. Hey, amazing. Thank you. That's amazing, Craig. Yay. Anyway, let me switch back to my slides. Oh, it's broken again. Why does it keep doing that? Anyway, so a couple of news things I just found really, really interesting. For those that follow IoT.com.au and the adventures of Steve Nash, I feel that's like a whole cartoon series right there, especially with that slide. Anyway, they've been doing some really amazing stuff. And like we're connected on LinkedIn, well, as you can see from that screenshot, because it's got first on there. But Steve Nash is doing some really cool stuff in the smart house IoT space, which is super interesting, with some really good partners involved too. I want to say realestate.com.au, but it was one of those big online real estate players. Pretty sure it was Real Estate. But there's some really interesting partnerships that they've been working on, and also just helping make that whole seamless smart house mini life hack things more seamless for, the non-tech folks, and being able to connect stuff up, because, we all do it as techs, but we want the consumers to be able to adopt it too, without needing to go down to, soldering things. They can if they want to, but makes it more seamless. But if you haven't checked out some of their blog posts and some of the fun things they're working on, now they did actually get into the NFT stuff recently, and also digital twin sort of setups alongside this smart house sort of build out that they're doing. Incidentally, and I was totally thinking it while I was saying it, but if anyone knows somebody or is able to do a digital twin talk, we've been trying to line someone up for a little while, so would love to find out more about that. Anyway, again, reach out, all the channels, you know where. This one I saw recently. So I've been doing a whole bunch of home renovations lately, and smart mailbox with a solar panel actually was a Hackaday post in February. Heaps of fun. Like this thing, I've seen a lot of these, and I'm sure you all have too, being built out of just, letting you know when there's a letter or when there's parcel, when there's something gets put into your letterbox. So this one's really fun to check out. And speaking of smart homes and smart things and smart mailboxes, for those in the Discord, there was an interesting conversation recently that Michelle Howie actually tweeted about, because, like I said, I've been doing some home renovations lately, and one of the things I've always wanted to put in was a smart toilet. So there was some chatter around, I've been looking at options and like integration things. So, and this is going to be a talk once I finish tinkering with some things. But essentially what I'm doing is I am putting in a smart toilet. The first one, there's a few probably going in, but I'm hooking it up to the PIR sensors from the security system, so that if temperature is below this, then seat warms up as you walk towards room. Because during winter, that's a mini life hack right there. Anyway, and that's just using Home Assistant, because I'm sure some of you are already using Home Assistant. Home Assistant's fun and tinkery. Anyway, whole other world you actually need power near these things as well. So I've got remodeling a couple of things at the moment. Anyway, the interesting thing I found with this is, not interesting, because they get really expensive. So I'm actually getting one of the seat ones from Bunnings, and you can literally pick these up off the shelf. And anyway, whole other world to explore right there. But it was just something that lit up the Discord recently, because I got some interesting reactions. You might be wondering, why is there a remote control with this thing? and I'll let you know because I don't quite know yet. But I also found that interesting. Anyway, fun times. This will be, I'm going to do a presentation on this once I get this thing installed and tinkered with and whatnot. But, well, I say demonstration, but there's a limit to that. And, we're a PG operation here, so there's a limit to that. But anyway, I'm going to do a bit of a talk on it. It'd be a whole lot of fun. Speaking of doing talks, wait, let me switch back for everyone's reaction. Tuning in. Oh, amazing. Someone else posted about the lands that they're currently in. So, hello. All right, let me switch back to Prezzo. Speaking of speaking, but we are always looking for talks. So I'm going to pop the link into chat now. And if you have got an amazing talk you want to do, or just something you've been working on, we would love to hear from you. So please reach out on either that form, the Discord, the meetup. We would love to chat, or just reach out to one of us on social. We're all very seasoned, experienced speakers, so would be more than happy to help first timers, or if you need help putting a presentation together, would love to be able to help there as well. So, one more thing. Let me switch over that one. If you haven't yet joined the Discord, I'll pop the link into the chat again. We have great discussions, including about smart toilets. That was, anyway, that was the whole thing. But I'll put the link into chat now. And now, on to the talks. So tonight we have Alastair Bate, who is an associate cloud architect at Amazon Web Services, where he specializes in cloud foundations and IoT. Alastair works to enable organizations of all sizes bring business value by taking advantage of what the cloud has to offer. Coming from a background in electrical engineering, Alastair has always had an interest in smart technologies and IoT, regularly identifying ways to build and work and why is this tricky? Build, work, and personal smart systems. The latest of which being a smart pool thermometer and a facial recognition gate. When not working on the cloud, Alastair is a keen traveler, continually exploring new places, particularly ones with good beaches, music, food, and space. No, I threw in that and space thing at the end. Because wouldn't it be fun to go touristing in space? You know what it would be. Anyway, going to bring Alastair, without further ado, let me take this slide off and bring Alastair. Hello, Alastair.
Thanks, Steve, for the introduction. I wish I could be a tourist in space, but not just yet, unfortunately.
Soon though, right?
Definitely.
All right, let's, cool. All good to go. Did you want to share your screen? Oh, wait, I have to do that.
Should be there, ready for you whenever.
Amazing. And just before we get underway, if anyone does have any questions, comments, or emojis, please pop them into the chat or on the Discord. I'll be monitoring both, and we'll get to them at the end. So over to you, Alastair.
Fantastic, Steve. Thanks so much. Well, hey, everyone again. Thank you so much for having me tonight. First of all, I just want to honor the traditional owners of the land on which we gather today. I am today joining you on this YouTube stream from Sydney, Australia. But naturally, we have so many visitors from around Australia and around the world. So again, I'm a cloud architect at AWS, and I'm particularly a cloud architect in the public sector, working with a lot of universities, educational institutions, government organizations, and always helping them to move to the cloud. As you probably gathered already, I am really interested into IoT and to space as well. Now, I don't think in the live stream you can see my entire shot, but I do have a space rocket behind me and the space station. So when I spoke to Steve a while back, thanks, about the topics we could talk about, naturally, this will be focused on IoT, but he really wanted to see how I could throw in a bit of space as well. So what I really want to talk to you guys tonight is about what AWS offers for IoT. So anywhere from the basics, the business value, and some of the more industrial uses that we can get out of IoT. From there, I'm going to bring a bit of robotics and space into it, in just what we have to offer. Now, I know this is going to be a broad ranging session, so it's going to cover some of the basics to more of the advanced uses, but I really want to tailor it to the people watching today. So if you have any questions or have any specifics, feel free to put it in the chat, and I'll either address it during the talk or I'll get to you later in the evening. But without further ado, let's just start with some of the basics of what is IoT. Now, I'm going to assume that since you guys are here tonight, you have some interest in it. You may have a sensor at home, or you may do it for work. So based on that, you probably already assumed the fact that it gets some data out of whatever you're doing with IoT. It produces something and it allows you to figure out what actually is happening in real life. So knowing that, and if you knew the state of absolutely everything, whether that be what's in your house, what's in your workplace, what's across a giant farm, what could you actually solve? And what I really love to start talks with is what's possible, because it's an endless question. Where can you actually go and build with IoT? It's starting with improving efficiencies, productivity of industrial processes, monitoring patients' health, farms. I really wish we'd be at the point where we have self-driving cars, all examples of IoT. And there's just so many more opportunities to come. And just wait, we'll see what happens with space and the IoT that can come from that in the future. But naturally, why you may be tinkering with IoT in our backyards just for the fun of it. And I'm really excited. I'm going to give you some live demos in the AWS console and what I've actually deployed around my house later this evening. But naturally, a lot of businesses, they don't care about the physical IT sensors themselves. They really want to get the second part, the actual value out of what IoT brings. And that's where I'm really excited to talk to you about how AWS helps you do that on a lot of scale, at the edge, in the cloud, and all places in between. And that's where we do it, is to actually get value for IoT. So we're trying to get data-driven discipline, intelligent decision makings, efficiency. Another personal one is safety, trying to improve the safety and experience of people, getting good products for people, and creating new services and business models. And as I talk through tonight, I'm going to go into a bit of depth, but also I just want you guys to remember this is what we're trying to do IoT for. So you've gotten the kind of the sales speech spiel at the start. I'm going to quickly change my screen to see if there's any questions so far. Exactly. That's Tim. That's why I really want to cover the actual sensors tonight. So we're gonna get that in depth. But let's go into a bit of what AWS has to offer, because that's why you guys are at least listening to me tonight. And we break it down into, if I can get the right slide here, 3 fundamental areas. And we call it the IoT virtuous cycle. It's the analytics services that drive decisions. But then to get the data for those decisions, you actually need to have devices. So how can I then control, manage, and secure these devices at scale? But then, of course, well, how does these sensors actually provide data? Well, then you need to actually build that software to provide the data to the devices that then provides the data into these analytics services. And this just keeps going around and round. And I know if you're anything like me, you just start to see those cool numbers come through, and then you just want to keep adding more and more and more. Oftentimes, particularly when I've been living with my family, it drives them mad because I'm like, well, I want to have some smart light bulbs. But I'm like, well, I'll get to the technology later. Let's just put the smart light bulb in and we'll enable a light switch later, which drives them crazy because then they have to go and use Google or Alexa or one of those Siri products to actually control all of these devices. So let's break this down into a few different areas and all of the AWS services that are on offer for each. And there honestly are numerous. There are so many different options to help you facilitate all of these different options to get your devices programmed, to get connected to AWS, and then actually to get decisions based on that. So let's start with one of these, because otherwise we could spend here all night. And I'm not going to lie, we could spend hours on this topic. So again, if you have any questions, feel free to put them in the chat and I'll try to get to them as we go along tonight. So let's start with the software, because as developers, you guys know that you actually have to program these sensors to get the data first and then get it somewhere. So how do we do that? How do we actually create, build, and operate these intelligent devices that work with AWS IoT, because we want them to connect to the cloud and provide the data there. So let's start with how we can actually integrate devices into the system. And there's two general areas that you generally want to actually implement. And that's either microcontrollers or microprocessors. So I know generally I have a device on my desk, and in the cleaning up for tonight's presentation, I've put it somewhere. It's not behind me, is it? No. But something like a microcontroller could be anything from a Raspberry Pi to a Node MCU to something even smaller. These are often built in. They have maybe Wi-Fi, Bluetooth, a whole bunch of compute power that actually lets you run something from anywhere from a robotic vacuum cleaner to a light bulb. But then there's even smaller ones. Sometimes they don't quite have enough power to do everything, but they do some small tasks really well. And that's where you may need to have something boosted. So to allow the development of these, we provide two different stacks. The first is the free RTOS software, or a SDK, a bunch of software library that's built up to allow you to directly communicate with the cloud. And the second one is one of these first edge services that we offer, AWS IoT Greengrass. And what IoT Greengrass does is it extends the cloud to your local environment. I have a really exciting example of this a bit later in the speech, where I talk about how I had made a smart Christmas tree over the past break, going back to you only have spare time over Christmas to build some things. And so naturally, this smart LED strip, which connected to a very simple Node MCU Arduino controller, didn't have the power to directly communicate with the cloud. So to bring the cloud a bit closer to me, metaphorically, I deployed a Greengrass solution and allowed Greengrass to do that communication for me. So between the two of these, either using FreeRTOS SDK or the microprocessors themselves, you can then connect to AWS IoT. But what does that actually mean? You're probably wondering, okay, what is this software? How does it actually enable us to do things? Well, what we first want to do is connect to devices on the local network, and then enable them to provide data to AWS. So we can either provide local connectivity to edge gateways, AWS IoT Greengrass, and then maybe have a device in between that again gets the data directly to the cloud. So I know a lot of you may not be aware of what the cloud is, but we define it as the delivery of IT infrastructure, IT services over the internet and on a pay-as-you-go model. So that means you're connecting and using services as you go. Now, I know I'll go a bit slower in a second because we're trying to get the basics here, but what we want to do is be able to send this data back and forth to the cloud. I'm going to pause here. And now, sorry, I'm talking to my screen over here, but what we have is the ability to do a lot of MQTT basics. So whether that's publishing messages to the cloud, subscribing to messages on the cloud, downloading, uploading systems, or even using some services such as IoT device shadows. What we can do is get the data we need up to the cloud and then back down so we can then act upon it. And what we do offer is a really quick and easy ability to do that at a large scale. Now, I know a lot of you at home, again, probably are looking at your one device, wondering why scale is important. But as you try to get a temperature from your bedroom, imagine trying to do that for a large hotel. Yes, it's easy to deploy one Raspberry Pi temperature sensor into your bedroom here, and you probably have a few hours. But imagine if you were the one tasked with deploying it across a 1,000-suite hotel. That would be a lot of work, right? So we really want to cut it down and make it as easy as possible. So the thing you really wanted to be talking about tonight, the edge. Now, there are a lot of edge services that AWS offers, but I'm going to focus on one particular one tonight, and that is IoT Greengrass. You heard me mention it before. But what this does is extend a lot of the AWS services to your local environment. So with this one, you don't actually have to send your data all the way to the cloud. It can actually save you time, whether that be literal milliseconds or the time it takes for devices on your local network to communicate. Because you only then have to send the data that you need to the cloud to be kept, adjusted, or acted upon. Another cool example is the way that you can actually deploy smart technologies or smart decision-making technologies to the edge. An example of that would be machine learning. AWS offers a large amount of machine learning systems. But how can you actually use these at the edge to make your house, your industry, your farm a lot smarter? So bear with me for a second. Let's give yourself an example. Let's say we have an unusually dry summer. We have sensors across the farm, and they're all picking up the same data that is coming through to them, that the water isn't at the level that it's needed to. Now, the machine learning algorithm will say, okay, it hasn't rained for 1 day. That's okay. It's day 2, hasn't rained either. Day 3, okay, it's starting to get worried. And what, after a period of time, it may actually choose to do is run at the edge an algorithm to say, turn on these sprinklers. That's a very basic example. You can start to use these machine learning models for anything from who's coming into your home at night, what time should you be alerted, or to hopefully one day fully self-driving cars. So that is the basics of the edge and actual software that we can allow to communicate with AWS. But then there's the next part, and that's the actual connectivity and control of the devices. So how can you then securely send the data that is generated to the cloud? Data privacy is a really big issue that we have. Everybody's worried about their data being published to the internet and accessible. And it's a particular example of when you're at your house and you're playing with the data of when the door is open or when the windows are open or when your fan's on. That information shouldn't be public. And we really want to help you secure that as well. So our core AWS service behind IoT is IoT Core, as you could imagine. It allows you to securely connect a whole bunch of devices to the cloud and then provision them, manage them, and keep them updated. It allows us to do it, again, at scale. And an important thing, it offers a cloud MQTT server for you to route messages, react to messages, and do stuff with that data. And remember, you have the whole AWS services behind you. So once you get the data to IoT Core, it's then a gateway to take advantage of the hundreds and almost thousands of servers that are often on offer today. And that's where you get some cool stuff to be able to be used. Now, this is a really fun slide for me because this is the thing that I'm going to demo to you a bit later tonight. AWS IoT Core for LoRaWAN. Now, just to kind of put some get some activity happening in the chat. If you happen to know what LoRaWAN is, give us an emoji, react, or put up an example of a LoRaWAN device you may have used. And while you guys do that, because I know there is a bit of delay, let me start answering the question. IoT LoRaWAN is a low-powered over wireless infrastructure that allows data to be transmitted up to almost 20 kilometers away. An example of this would be a low-powered temperature sensor that you put out in a farm or in a classroom at a university. These sensors pick up a device, but use very little power to do it. They send the data then encoded over a wireless frequency using very low power and are picked up by gateways. These gateways then forward the traffic to, in our case, AWS IoT Core for LoRaWAN and allow this data to be ingested, onboarded, and reacted. One example of this that we've used in one of our customers is CO2 sensors. So naturally, over the past few years with COVID, everybody's aware that we need to have good ventilation and flow. Now, cabling up a CO2 sensor or an airflow sensor to a classroom across a wide campus is really cost inefficient. So the way they managed to overcome this issue was to actually deploy LoRaWAN sensors and put CO2 sensors across an entire campus. What this brought on is a large scale amount of data that they were then able to compare and react to, knowing full well if there wasn't great ventilation, they'd be able to actually pick it up and act on this data as they go. So That is LoRaWAN, and we fully support that. And again, the benefit of using it on AWS IoT Core is that it's pay as you go. So no more do you have to manage your own servers for these LoRaWAN servers. You can just start by adding a gateway, something like this. That's actually one of the things I prepared for you earlier. Now, not exactly this one. My one's running in the other room, but connect it up to AWS and start getting data today. Now let's keep moving along. So just for some technicalities, this message broker offers you the ability for two-way messaging, retention of IoT messages, query of services 0 and 1, and I believe 2 now. I believe that was recently released, and a whole bunch of topic spaces that can be customized. So no longer do you have to run your own MQTT server locally at home. It can be connected directly to the cloud. And I've had a lot of fun doing that. And then again, what can you actually do with these IoT devices? Well, you can obviously transform this data, filter this data, enrich it, but then route. And that's my favorite part. I love to have messages sent to me if my pool temperature is over 28 degrees, because that's rare. That doesn't often happen. And so I know if it's 28 degrees, I want to know immediately that I should go out and have a swim, particularly if I'm at home. Now, I haven't put any smarts together to actually know where my location is at a particular point, but that could be some machine learning thing I could do in the future. And don't forget all the analytics, databases, machine learning systems that AWS also has to offer. Now, one other cool thing, and here, I'll say it once, then you can say stop, just to hopefully not set off all the devices in your house. Alexa. We all love the Alexa voice service because we can automate our houses, turning on lights, turning off lights, turning on your fans, and potentially for Steve in the future, even controlling his toilet. What this allows you to do is integrate your IoT devices with the Alexa voice service to actually make these devices even more efficient. So let's say you wanted to control your entire house. Well, Alexa is a perfect way to do that. And as you guys are probably having at your house, I've just set off the one that I have in the corner of my room multiple times now. Well, let's continue on. So I know I've talked a lot and I'm almost done to the fun live demos, but let's just talk about one last thing, and that's the analytics services that are on offer. Now, there are a lot of them. There are so many intelligence-driven services that we have on offer, but I'm just going to really focus on 2. Siteways, first of all. So it's collecting data from your actual environment live and then ingesting it into AWS. You can then have your appliance as a local gateway and make informed decisions. Firstly, structuring the data in a way that makes sense, creating dashboards for people to use, and then processing that data to actually make models, learn from it, and act upon it. It collects, monitors, and enables you to use this data right at the edge. Again, another one of our edge services that we have on offer. Now, the second one will be QuickSight, but I thought rather than giving you some slides, I thought let's give you a live demo. Now, at this point, again, I've asked you to put some questions in the chat so we can go through it, because this is the actual point in the speech that I really want to engage you guys and answer some of your questions. Now, I saw earlier there was a question around device shadow. So let me just start with answering that. So a lot of IoT data, it appears for a second, but then could disappear. So there are a few ways around that. Either you can go and store this data in a database of some kind, whether that be structured or unstructured. Or what you can do instead is use a device shadow. And then what that does is AWS stores the latest value of a state, whether that be a temperature, an open-close system of a door, or a whole bunch of other things. What then happens is other services can query that device shadow on AWS. It's basically a digital twin where the physical sensor is replicating its state to the cloud. And if you change the state in the cloud, it replicates back to the device at home, making it really easy to get the latest data of a physical thing in real time. I'm really keen at one point to automate my garage door. So I'd use a device shadow to update the latest state of the garage door in AWS IoT Core. And then what I can do is create a website that when I go into this website, rather than going to the end device, asking it for its state, it will just go to this device shadow and give me a value of what it is. But anyway, you've heard me talk enough. Let's go into some cool stuff and look at some demos. So let me actually show you the next slide. You've heard me talk before about LoRaWAN. So naturally, the nerd I am, I went and created a LoRaWAN network at my house. Not very complex, but a very simple one that I thought would bring me a bit of value. So I went out, purchased a LoRaWAN gateway and connected it to AWS IoT. I then got a temperature sensor. Now, I'm pretty sure this temperature sensor isn't supposed to be permanently submerged. It's waterproof, but naturally, they're not always fully designed to be in the water all the time. But I went and put that temperature probe in the water. So what this temperature sensor does is actually collects the temperature of the pool, the outside temperature, and sends it back to AWS IoT Core. So this is the overall architecture diagram. Again, as a cloud architect, I really love putting these together so people can visualize what's happening with their data. But let's go and have a look at this in practice in the console. So what I have here is our test console. It shows all the data that is coming through directly to AWS IoT Core's message broker. You'll see here's the LoRaWAN temperature pool topic. You can see a whole bunch of metadata that's come from the actual gateway itself, the encoded payload data, and then what I have in the background is a Lambda. And a Lambda is a serverless application that service that AWS offers that allows you to run code without actual servers. So I take in the payload data that's encoded here and output the actual transform payload data. So what I can see here is the external temperature, which is the temperature of the pool, is at 22.5 degrees today. And then the outdoor temperature is 21.96. It's not too bad. I'd probably get in there if it wasn't so cold outside, if it was a hot day, but probably not the most comfortable hot temperature at the moment. So what I then do with that data is I send it to IoT Analytics, our specifically built service to ingest IoT data. And what I do with it is I manipulate it. I add some attributes in using some pipelines and some data stores. So I take it in here. I've used this fully managed service to actually transform the data and save it. Here it takes it in, and we can probably see the last time we actually got a message, which I actually had to go and reset it today because I think the rains may have made it a bit wonky over this past week. But let's see if this loads. Again, the live demos are always fun. No, okay, not coming up there. But I can assure you there has been data coming through. And once I do collect that data, I then save it in a data set and make it available for QuickSight. So QuickSight is our business intelligence service that allows you to create really easy to use dashboards for people to take in data. And here is showing the temperature of my pool versus the outdoor temperature for the past, where are we at now? We're at March, 2 months now. Now, one thing I saw when I actually put this dashboard together earlier this week is how little the pool temperature actually changes. I could probably go back to science class and actually think about, I think it was the heat capacity of water, if I am remembering correctly. And remember, it is pretty good at holding its heat. So you can see here, when we got up to the hottest day of around 42.9 or 45 degrees, the pool temperature was at a very nice 28 degrees. It came down over that week as it was cooler temperatures, and it has slowly come up with the hotter temperatures. However, if I put an insight on this, I'd have to take a guess to say the temperature of the pool is probably going to keep going down for the moment unless something else does happen. You can obviously make some cool insights, and I love to see that the pool temperature was at 28. I purposely left off the lowest temperature because I didn't really want to know what it was. And then also the actual temperature over time, so how much it varied in a day, generally only by about a degree, and some cool other data here. So that is this, and that's, again, the architecture diagram that we can need put together. Now, naturally, this is just one sensor. My personal budget, ooh, that's always fun. No preview of that. Anyway, let me talk while I fix those slides. Now, naturally, my personal budget isn't enough to have 100 temperature sensors over my own house, nor is it probably needed. But naturally, as you start to get more sensors on and collect more data, you can create more and more in-depth visualizations and tools. Now, the other demo I wanted to at least talk about is my smart Christmas tree. Unfortunately, and naturally, not being Christmas anymore, we can no longer have a Christmas tree up that I can show you. But what I decided to do over Christmas was take an individually addressable LED strip that I had. It's connected to a Node MCU, as you can see here, on an ESP8266 chip that has Wi-Fi and connects to your local network. I wrapped that LED strip around the Christmas tree and used that as my Christmas tree lights for this year. Now, definitely go and feel free to look it up. WLED is a great open source piece of software that allows you to control these LED strips, combine them together, even create some cool light shows if you put enough together. And it allows for a bunch of different effects. My particular favorite one was fireworks. But naturally, that wasn't good enough because, yes, you can control it from your phone, but I really wanted to integrate it with a bunch more things. So what I did is a very practical example of the Raspberry Pi. On the Raspberry Pi and Greengrass version 2, I extended the cloud to my local environment. In this case, that ESP8266 can't directly communicate with AWS IoT Core. It just doesn't have that compute power required. So what I did is I deployed on the Greengrass version 2 on the Raspberry Pi a MQTT broker. And that was replicating certain topics that were in the cloud. So over my local network, over that Raspberry Pi Wi-Fi network, that LED strip was communicating its current state and getting updates from that Greengrass. My Raspberry Pi, which again is sitting in my house, then communicated back with IoT Core, the actual state and any updates that were happening on those particular topics. For fun, I then sent the data to IoT Analytics and stored it. Not this time, but next time in the future, I really want to see who's in my family starts using the lights, turning them off when the Christmas lights are on, and a whole bunch more. But the cool thing that we got to do this Christmas was actually create an API. So I created, using API Gateway, an endpoint that allowed you to control the brightness, the state, whether it's on and off, and the actual effect of the Christmas tree itself. And naturally, I then had to put a static website in front of it. And that static website allowed you to go and click on it, have a look at the state of the Christmas tree. So turning it on and off, creating a cool effect, changing how bright it was. That website sent a command over the API to the API gateway, which then controlled the IoT Core state. So again, going back between the edge and the cloud, these services were all able to communicate and at some point drive me mad when I particularly gave access to my parents to go and play with it. When trying to watch TV, it was very painful just to let it sit there and have the effects keep changing. But nevertheless, it was quite fun and a really cool example of what you can get up to combining the cloud and actual IoT. Imagine if you put in a motion sensor. So as you came in the door, the motion sensor the cloud, and you had some logic there to actually go and turn on your Christmas tree. So I'm just going to take a break, have a bit of a drink of water, have a look in the chat again to see if there's any questions. And HAS integration. Now, off the top of my head, I can't remember what HAS stands for. It sounds very familiar, but I'll get you guys to explain it out to me a bit later. Cool. And now what I'm going to do is cover some of the topics that Steve definitely addressed at the start. And that's going to be some robotics and some space stuff and what we have on offer. Again, not directly related to IoT, but I'm really curious to see what ideas you all have. So let me switch back to my slides, which I believe are here, and let's focus on robotics. So again, what my background is electrical engineering. That's what I studied at a university and did for a period of time. During one of those courses, a real big focus was on robotics. So naturally, when you're dealing with robotics, you have to play around a lot. I remember back in one of the projects I did, we were asked to make a robot that would go up to the elevator, click on the link. My timing's off a bit here. Anyway, I'll pause and come back in a second, and click on the elevator button. Now, naturally, as university students, we weren't efficient and we didn't have any test-driven automation. We just had the robot there and we keep changing one line of code and keep running it again and again. Is that the most efficient way of doing it? Definitely not. Definitely. Wouldn't it be so much better if we could simulate it in the cloud? Well, that is definitely where AWS comes in handy. But the problem is a lot of these simulations often use high compute power, need a lot of expertise, and a lot of infrastructure. And at the time, that's what we had to do. I remember having one of my own laptops crash because I kept trying to run a simulation and it not work. So what we had to do was put together some reproducible scenarios, some extended tests, and we actually wanted these software to run fast. I really wish we had access to the AWS, robotic services back in those days to make it a lot easier. So what we have on offer is a way to decide on the actual test scenarios you're going to make using the robot operating system and a few others. You can build your robot in a simulation, choose the world that you're going to simulate it in, whether that be somebody's house, the test environments as a whole bunch, and define those test scenarios. Now, one of our oldest customers, one of the customers that have been using the service for quite a while is iRobot. They both also use the IoT services as well. But what they do in this case, I think I keep leaning on my keyboard or something. Anyway, what they use it for is to the release velocity, obviously improving their tests, making sure they can try out different full layouts and scenarios, and obviously bringing down costs because they can do it at a high scale. And on AWS, again, you only pay for what you use. So they can start up and use a lot of these simulations as needed and then stop them when needed. So that is robotics. Then let's head into space. And let me just go, before I continue on, let me just fix my slides so they don't keep moving forward. There we are. Perfect. So this is where you'll have to stop me because I could talk about space all day and not just the AWS space related systems. I've been really passionate about space since a young kid. I got to go and see a space launch in Cape Canaveral back when a satellite was being launched for the Department of Defense into space. Unfortunately, not quite SpaceX at that time. That was a bit before they were around. But I'm keen to head back there and see a bunch more launches, hopefully now that COVID's starting to slow down. But nevertheless, the space industry is really growing at the moment. I'm sure you guys are aware of all the things that are happening. There's so many more satellites out in orbit at the moment, collecting so much more data. And the cost of space is really coming down. I'm really excited to at some point get into space. I'm not sure I'll be one to go to Mars. That's a long way away, but I wouldn't say no to going into low Earth orbit for a few days. And naturally, as we keep moving forward, we're going to have a lot more satellites collecting a lot more data. And we really want to bring down those costs as much as possible. What we can do is actually increase innovation because we bring down the cost by making it only pay for what you use. We can help you transform that data and get it to people, into decision makers as fast as possible. We can help you use AI and machine learning to actually evaluate your assets and make smart decisions based on them, and give you some infrastructure and processes that allow you to focus on what you're trying to do, which is the mission itself. Now, please put in the chat if you have your own satellite or if your organization does. I'd be really keen to hear about it. I know personally, I don't have a satellite that I've been able to try out, but there are some cool ones that you can connect to that provide some weather data. And that's where AWS Ground Station comes in. So let's say you had the ability to create your own satellite. You then were able to launch it up into space. Well, then if you're aware of what any space services offer, is you'd have to have a ground station to downlink all that data. Unfortunately, your Wi-Fi router out the back is not quite good enough to reach to outer space. But creating these ground station is a lot of cost and a lot of work. So what AWS provides, again, is a pay-as-you-go service to pay for only the time you're downlinking data and nothing else. meaning that as your satellite's coming over, let's say tonight it's 7, it's a bit past 7, let's say 7:45 tonight, we'll program the Sydney satellite dish to connect to your satellite and downlink the data that's coming over. Whether that be getting satellite imagery of a latest farm, fire that's happening around the world, potentially flood information. You can downlink that data, get it direct into AWS, and then you have it very quickly to be able to use, manipulate, and make actually appropriate decisions on. Now, I love talking about some cool people, and NASA is on the top of my list for that. NASA, a customer of ours, and they use our services for a range of different things. But in this case, what they use AWS for is to get data from Curiosity's Mars rover. So naturally, this isn't just about the ground station services. They use a whole bunch of other things. So imagine back in, let's say, I was about to say the olden days, but it could be 10 years ago now. Trying to get data off a rover would take probably weeks. By the time you have a radio antenna, get enough information, you get it into a system, and then you augment that data and make it usable, it's probably not going to be available to the public for quite a bit. But now that 2 weeks to deploy the application and stream it to the world is really made it so much more easy for the Curiosity rover to get the data in. They can downlink data, they can bring it into a CloudFormation system and CloudFront and enable people to access that data so much more quickly. I know particularly when it first launched, I was really curious to access all this data and get it really fast. And also all this automation and machine learning allows them to do quite a bit. So I know these are just some small use cases, but imagine what's possible. When you combine the actual data that you can collect from out of this world, send it down into AWS. Maybe you can even modify some IoT sensors to create some cool learnings, some machine learning, and a whole bunch of other things to do some cool stuff. So that comes to the end of my official presentation here. But again, I'm really keen to see if there's any questions about any of the particular services that I mentioned today, or some of the use cases, and we can talk through them. Now, I'll hand it over to Steve to see if he wants to facilitate any questions and ask anything, and we can go from there.
Amazing, thank you. I have a couple of questions, but yeah, if anyone does have any questions, please drop it into the chat or put on Discord, because I'm watching both at the same time. Dual multi-threading? No, anyway, I'm watching both at the same time. But anyway, I was actually I have a NASA joke, so I was gonna start with that. But do you know how NASA organizes a party?
How do they organize this party?
They wait. Let me get my soundboard ready, because it's new. It's new. Anyway, they plan it. There we go.
That's nice.
It's open source, so please feel free to use it. Again, if anyone does have any questions, please drop them into the to the chat. I actually have a few. I made a list.
Please.
Starting with the device shadow. Yeah, I actually hadn't seen that before. That's actually cool. So it creates a virtual, almost like a virtual mirror device, or a twin device, if you will, and then sends it over when device is available, like connected or whatever else. Is that also able to handle over-the-air update, like firmware upgrade, like almost like a test before it actually deploys to device?
AWS IoT Core does support over-the-air firmware updates. I don't think I wouldn't confuse the two services together. IoT Shadows is about getting the data, representing it. But yes, firmware updates over the air are supported for IoT devices.
Okay. No, just the IoT dev in me was like, oh, I can run device tests on it first before it goes live. Like, oh, that would be great. But no, that makes sense.
Not quite that. It's not a complete digital twin. No. You'd have to go and use some Lambda tests or something like that. I'm sure it's possible, just not with that particular service.
Totally putting in a feature request. But anyway, the other one I had was I'm just going to ring up Jeff and be like, hey, no. Also, I actually had a similar question around Greengrass, whether Greengrass was able to store OTA to go to a device that connects to, because the green grass gets deployed and then everything kind of talks to that and then that talks out, right?
Yes, you're right. That's a good question. Oh, so the way
Ask
green
all the
grass
tough
works,
questions.
I know. Again, I'm not lying. There's so many services on offer in IoT. I love to play with them all, but there's some use cases that I haven't come across. So just for your awareness, what you can do with Greengrass is you can build what's called components. So in this case, the MQTT broker is a component that you deploy to the Greengrass at the edge, and you can reuse it a bunch of times across multiple Greengrasses. You can also deploy Lambdas and a whole bunch of other things. I'll have to get back to you on that. I don't know the answer, whether you can do OTT over the air updates from Greengrass directly.
Okay. And then another green grass question. I know that's why I didn't expect. Oh, yeah. It was literally just I was watching your presentation, like, I wonder if it can do. Yeah. The other one is so does Greengrass cache? It obviously runs its own localized broker. If it loses connectivity, is it able to cache and then when resync or sync? Yeah. Cool. Which
Completely.
would I mean that would make sense.
Yeah, it's really designed. So one of the cool things I did earlier this year is we have another edge service called the Snow Family. So I won't go into it depth tonight, but they have a few things from anything from a snow cone to a snowball to a snowmobile. Now, I'll pause for a second just to leave you in confusion about what those services are, because that's what I really love to do when I go to my friends. What did you do at work today? I got a snow cone, and they look at me very puzzled. But now that the moment has paused, sorry, do you want to take a guess?
Wait, anyone watching, and I know there's a bit of delay, anyone watching want to take a guess as to what they are? I was going to say they sound like, I probably need to get my soundboard ready. They sound like cool services.
See, I like that thinking completely. So what the Snow Family allows, it's originally designed to be a method for you to transfer data from your data center, your home, into the cloud. So literally this snowball is an 80 terabyte kind of starting at a hard drive with some compute around it that arrives on a delivery truck that you can literally plug into your data, transfer data to it, send it back to AWS, and they'll load it up into their S3 or another service in this case. Now, snow cones are a bit smaller. They are literally this cute little box that is heavy duty. The UPS guy arrived at my house and just gave it to me. And I'm not sure, it feels very weird. It's almost like somebody was delivering you a hard drive, but rather than it coming up all packaged, it's just delivered straight to your door and somebody gives you a hard drive. Now, it's a bit more rugged than a normal hard drive. But the thing you can do with snow cones and snowballs is have compute capacity on them. So they can run off the grid, they can run a server, and in this case, I ran Greengrass on it. So that localized server could be put out on a truck or on a boat or on a plane even, and it doesn't have to have connectivity to the internet. Everything can communicate with Greengrass directly. And eventually, when you do reconnect to the cloud, data can be transferred and such. But let's say you're in the middle of a farm and you had internet connectivity once a week for some reason. Yes, you'd be able to operate your farm completely using a bunch of AWS services that are deployed to the edge as well.
Yeah, that makes sense. And last question I had, but if anyone wants to drop anything in chat, but last question I had is just one of like geeky curiosity, but you kind of touched on a little bit, but have you done anything with IoT fog computing, where they a whole bunch of devices kind of all like talk to each other? It's a niche thing.
Fog computing? No, I can't say I have. I'd be keen to hear about it more though.
Oh, I've only lightly tinkered with it myself, but and Craig just said got a whole bunch of things that you could use it for, but not fog, but the snowball stuff that you were just talking about. The delay up here in space. And we do have another question, but I'll get to that one in a sec. Fog is basically you have a whole bunch of IoT devices that are able to talk to each other and basically do the compute across the collective rather than at edge, rather than communications go out directly and get a response back and stuff. Kind of like Greengrass, but microservice Greengrass. Oh, that's probably a new service in the making.
I wish I was in charge of namings, but that sounds a fun one.
Yeah, it's one of those like edge emerging things I'm always interested to see. So we do have a question from Matthew, which is, are you aware of AWS using a snowmobile in Australia anywhere? That is actually,
I'm
yeah.
personally not aware of any snowmobiles that have been used. However, snowmobiles, for those who don't know, are a full truck that drives up to your data center and plugs in. Have I paused for a second? Yeah, there I am, back. Yeah, so the snowmobile literally drives up. It's a semi-trailer with a bunch of compute in the back of it, and it drives up. You plug the cable directly into your data center and can transfer a whole wad of data. I don't know off the top of my head how much, but it's a semi-trailer. It can take a lot of data. Comes with its own security team, 24/7 security to watch over the truck to make sure it's secure. Then it drives back to AWS, plugs back in at our data centers, and transfers your data back in. Again, I don't know off the top of my head of any AWS customers that have used it, but if you are keen to use it at your organization, please let me know, and I'm sure we can look into some use cases.
See, two things just popped in my head when you were describing it. One is, well, it puts a whole new meaning to containerization. And the other one is the security team. Like, I could just imagine like one of those, presidential SWAT teams like running around like protecting everything. Yeah, whole other world. No, that is a really good question, and I kind of really want to see one now. But yeah, anyway. Any other questions? Drop them into the chat. Actually, I have one last one while we're waiting for the stream to catch up, in case there's any last ones, which is, I always love asking everyone this, particularly those of us in tech, but what was your first computer?
My first computer, let's see. I don't remember the brand, but I had an old laptop from my parents. So the first one that I really remember was back in primary school. What they had was those brightly colored iMacs. So we went into the computer lab, and they had the ones that had the giant back to them, but they're all multicolored. So that was the first one. And I think that's what really started getting my family onto Apple computers. And to be fair, I've probably been with Apple ever since. Very good at marketing, I have to say. But definitely, we had one before that, because I remember trying in those early stages, trying to use dial-up internet. It had its own modem built into it. Oh. You try to get the laptop on. I don't think I've really been a patient person ever, but that probably really still pushed my patience back when I was younger. So yes, those would be my earliest computer memories, at least.
Oh, that noise too. I'm not going to do it because I can never do it right. But that noise, you just don't forget it, like, ever.
No. And I complain now when our internet speeds at like I think generally on a day-to-day basis, I think I've gotten it up to above 90 on a 100 plan. So if for some reason it goes down to 40 for some weather-related issue, or somebody else is streaming too much, I've obviously grown a lot to the higher standard of internet that we have these days. To be fair, though, if I'm at home and I've wired up the house in the network that it needs, it's probably my fault if it goes down. It's unless the cable is cut at the street, I'm probably the one slowing the internet down.
And let us not mention the 4-hour reconnects on dial-up. Like, so many memories.
Wow. I'm really good. We don't have to go back into those days.
No, thank you for the talk tonight. If anyone does have any more questions, Alastair's in the Discord now, so you joined earlier. So please reach out on there. And thank you for joining. Wait, I have one more thing. There we go. Thank you very much.
No problem. What I'll do is I'll put in a few links. Some things you can get started with AWS is the Greengrass workshop. So I don't think I can post directly to the chat, but I'm going to put in a private chat to Steve, and then maybe he can repost it. There's 3 links here. There's a workshop to play around with Greengrass and putting it maybe on your local system. And then AWS EduKit. So it's a compute that's specifically designed to work with IoT, made for AWS. So you can play around with a bunch of workshops and try them out there. So if you're keen, have a look at them and see where you can go with them.
Amazing. Thank you. And yeah, again, if anyone wants to reach out, check those links out. And if anyone wants to reach out and chat some more, maybe to arrange one of those truck, was it snowmobile tours? No, that's maybe soon. But no, thank you very much.
No problem. Thanks, Steve.
How amazing was that? So again, reach out, say hi, check out those links. Reach out, say hi if you want to chat or if you want to find out more about stuff. The edge stuff I found really interesting. I need to play with Greengrass a little more. So anyway, let me bring the slides back. And Craig and Nathan are talking about AT commands. It still gives me cold shivers. I don't like AT commands. There, I said it. I have used them on some, I'm going to say boards. I don't want to mention the brand name, but yeah, I have done AT commands before. They're just, yeah, we're not going there. So that was this evening's talk. Yeah, my slides are, I don't know, I think I need a new graphics card or something. That was this episode this evening, this talk for Oz IoT today. As I was saying before, we are looking for new talks. So if you have got something cool you wanted to come share, maybe it's connected toilet, maybe it's about, I forgot to tell you about HAS. So HAS is Home Assistant. It's the abbreviated version. So you can run it on a Raspberry Pi and stuff. And yeah, anyway, it's tinkery, but I'm running it here. Anyway, yeah, if you have got a talk you wanted to do, maybe on HAS, maybe on smart toilets, maybe a combination of both. No, wait, I'm doing that one. Anyway, if you have got a talk, please reach out. We would love to chat and have a presentation on. One of some upcoming events, just wrapping up, I wanted to talk about, which is Brisbane IoT. Good friends at Brisbane IoT are running Sunday Mad Science. Bring a problem and seek an answer session this Sunday if you are in Brisbane. This is a IRL event, so if you are around, please check that out. Also, keep an eye out for our next event. We are not sure yet when it's going to be. If you want to get involved and help organizing events, please reach out as well. We would love to chat. And we've been going, actually, I think we're coming up on our 2-year birthday. Actually, we are too. There you go. Well, maybe we'll do the next one sometime around Eastery, and we'll Eastery. Sometime around the Easter break, or either probably a little bit after it, and we might do like a special birthday one. Anyway, stay tuned, and we will announce that one soon. Or join the Discord, because we will announce stuff there. And if you've got to talk, you can jump in the Discord. Anyway, thank you very much to everyone. I would switch back to my soundboard, but it's on the same screen with my slides on, so I won't do that. But woo, applause! There you go. So it's special sound effects. If you are around, drop into the Discord. We might jump onto Zoom if there's a few folks around that wanted to chat. If not, we can jump into the audio side of Discord. Next meetup, we are still looking at a couple of options to do the virtual thing again, so stay tuned for that. And if you've got any ideas around that, we'd love to hear. And that's the end of my slides. So let me switch my slides off so I can switch back to my screen. There we go. Thank you very much for joining us tonight, and we'll see you soon for more chatter in the Discord, and we'll see you for the next event.